Okay, I'm going to do a tutorial video here for you on how to draw your angle of insolation and ultimately how your solar panel will be installed. Before you're at this step, you really need to have decided where in the United States your solar panel will be located, or where your solar farm will be located. I'm going to show you the initial setup here. Let's say that you have reached a point where you've done your research. You know where in the United States this is a solar farm installation. The first thing we're going to do is we're going to draw the ground at that location, and we're going to assume that the ground at this location is flat for us. The next thing that we need to do is we need to create a normal line, and so what you can do is at any point on the ground you can have a line of intersection. Line that up on your protractor so that it falls right there. Hold your protractor so that the line falls here and down there, so you're nice and level, and then make a mark at 90, because a normal line is a line at 90 degrees to the ground. Take your protractor, make a nice big line top to bottom, and we can label that normal. Now, I'm going to pretend that you made a little bit of a silly idea or silly mistake, and you said that Granby, Connecticut was the best place in the United States to build a solar panel. So I'm going to model what it would look like for the angle of insolation here at Granby. So we're going to say Granby, Connecticut. And the reason I'm choosing Granby is because it's local and familiar for us, but also because it's not a location that you can choose for your own project. So Granby, Connecticut. And Granby, Connecticut is located at 42 degrees north. I want to show the angle that the sun strikes the ground on an equinox day, the day that Earth's tilt doesn't affect us. We're not pointed towards the sun in the northern hemisphere or away from the sun in the northern hemisphere. Before we go to Granby, let's actually visit a few other locations in the world and show how the sun strikes at that location. Let's start off at the equator. At the equator, the sun strikes the ground at 90 degrees. We would say, oops, I forgot my line of intersection there. Give me 1 second here. We would say on this day, there is 0 degrees of difference between my normal line and my line of insolation. You may notice a pattern here. The equator is 0 degrees. My angle of insolation is also 0. So there's a bit of a pattern there. Let's check a new location, the North Pole. On vernal equinox, or fall equinox, spring or fall, the angle of insolation is going to be 90 degrees to the normal line. And so we can do here a line of intersect. This is 90. Point there. Say from here to here. Insolation. Good. We would say that's 90 degrees to our angle of normal. Another pattern here, 90 degrees here at the North Pole, 90 degrees. What we're seeing here is the latitude of an area determines the angle between the normal line and the angle of insolation. So let's go back to Granby. We exist at 42 degrees north. So that means we can take our protractor and we can go 42 degrees away from normal. This is 40, 10, 20, 30, 40, 41, 42. We can take our protractor we can add an arrow. We're going to label this insolation. And we can show the angle. It is 42 degrees away from normal. Good. Now, we have drawn the ground, and the angle the sunlight will strike on this equinox day. What we want to know next is, if we have a solar panel, what angle should our solar panel be installed at? Many times students want to install their solar panel straight to the ground, or they want to guess it's 45 degrees, perfect between the ground and normal line. Now for us in Granby, that's kind of close because of our specific latitude. 45 is a bit close, but it's not perfect. What we want to have is an angle such that the solar panel is dead on with our angle of insolation. Or in other words, if I were to draw a normal line between my solar panel and my angle of insolation, it would be a line of 0 degrees. So that means my solar panel will exist at 90 degrees to the angle of insolation. To make my solar panel line, I'm going to put my protractor so that the angle of insolation sits at 90. My point of intersection is still on the angle of insolation line. I'm going to draw my solar panel. We'll slide our solar panel down a little bit, protractor there. Connect those two lines. And this is our solar panel. At that point, our engineering drawing is done. We've shown our latitude of our chosen location. We've created a normal line that's 90 degrees to the ground. We've shown the angle of insolation, and we've drawn the angle of the solar panel at this location. Now, if you're closer to the equator, your solar panel is going to reflect the reality that the sun is higher in the sky, and so it's going to sit like this more. If you're further up north, your solar panel will be more like this. You're going to use the map of the solar power across the United States to determine where in the United States you should be installing a new solar farm. Okay, I hope that's helpful.